Hello, testing, testing. All right. Hello and a good day to everyone. Today I'm going to be explaining chapter 8. In this chapter, it's mostly heavy memorization, not as heavy as chapter 6, and it's quite easy in my opinion. Now, there are three parts that we must cover: glass and ceramic, alloy, and then composite materials. Now, for today, I'll be going ahead and explain the alloy part. It's one more time I would like to rephrase. This chapter is for me is quite easy and doesn't require any understanding as much as the previous chapters, and mostly you have to read and memorize. So let's go ahead. Okay, now let's go with uh let's explain alloy. Okay, alloy or better known as supermetal. Before we go ahead on alloy, I would like to explain normal metal first. Normal metal. First, we would like to know its properties. And if you remember in your previous years, during Form 1 and Form 3, we also had learned about metal, its properties, such as, first of all, the first thing is shiny. Second is high melting point. Third is very good conductor. Fourth, ductile. And fifth, the last one is malleable. Now, for your explanation today, in this chapter, we will be mainly focusing on the fourth and the fifth characteristics or the properties, which is ductile and malleable. We will be focusing on these two. Um, it will be quite simple, so nothing to worry about. Now, let's go on first with ductile. Okay, now ductile. Let me sign in. Ductile. Ductile, the meanings of ductile is can be, let me adjust it, can be pulled into thin wire without breaking it. As you can see, thin wire without breaking it is the same thing goes as the image I've shown. See, a thin wire, it can also be, let's just say, let me show you an example. Ductile, ductile metal. It can also be short like this, the copper rod, copper wire. See, this is one of the characteristic of being ductile, which is quite easy, but most students mistake it by relating it back to being elastic. They think ductile and elastic is the same, which let me remind you, it's not. It's not elastic. The difference between elastic is when you pull it, it will go back. Let's just say I pull like this, I pull like this, and when I let it go, it will return back to its normal size. Meanwhile, ductile cannot return back to its state. So that is ductile. So let's move on to the malleable part. Oh, malleable. Malleable, or better known as in our bahasa, malleable, mampat, mampat. Okay, malleable. Malleable is the meaning is can be hammered into different shapes. In Form 3 or Form 2, we also had learned the same thing, which is we can change shape, change size depending on the metal. For example, let's just say I took this pure metal and I took a hammer to it, and when I hit the hammer onto the metal, Let's just say I hit it over here. And now what will happen to it? It will bend, not bend, it will bend slightly. So for example, it will have a little crevice right here where it will bend inside of it. And you can see it more clearly in this one, in this image. You can see those parts maybe were hit by hammered, so you can see it changes shape. Let's see malleability. Yeah, for example, see they hammered gold or press something into thin sheet without breaking it. Oh, see, hammering and pressing. This one, hammering and pressing. Now, why do this both of these occurrence happen? Well, let's go and check it out. So this is pure metal, pure metal. Now, for pure metal, the atoms arrangement is let's just see. We're going to put let's ask us ourselves the question: why pure metals are ductile and malleable? Why? Okay, first of all, ductile. Let's go with ductile first. This part will mainly focus on ductile. It can also be it is the same goes with malleable except it's backward. So let's go with ductile. Okay, now for ductile, let's just say pure metals. This is pure metal, right? Pure metals are arranged in. Alright, sorry, my bad. Pure metals for the atoms are arranged in orderly manner, and the atom has the same size. So remember this. You could remember this from chemistry chapter, if I'm not wrong, chapter 2, where you learn the atom arrangement. As you can see, this is solid, it's closely packed into another, and it's also neatly arranged, which means um, no abnormalities in here. So now let's begin. So, oh yeah, one more characteristic. It's also closely packed, uh, arranged. Actually, yeah, it's the same. It's the same. Closely, closely packed in an arranged. Eh, closely packed and arranged in an orderly manner. Testing. In an orderly manner. Now, atoms has the same size. So what happened is when I had mentioned ductile is an occurrence where you pulled the metal into thin sheets without breaking it. So this is what happened. First of all, this is an atom. As you can see, it matched the characteristics. All of it is the same size, orderly arranged, closely packed into each other. And then when you pull it, when you pull it, one force here, when you pull it with force and force here, it will occur something called in this chapter sliding occurrence. Do not answer in the exam sliding occurrence. You have to answer it differently, of course. Sliding occurrence. So what is the if you if the exams were to question you, what would you answer? Then this is my own. Actually, I've seen some YouTube videos that explain how to answer this type of question, which is when force is applied, layer of metal atoms slide over each other easily. Right. This is the RAM. This is the Y. Why? Why the sliding occurs? When force is applied, layer of metal atoms slide over easily. See, it's sliding, right? It roll, 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 and then that's how sliding occurs. Now, let's go with malleable. Malleable also is the same thing. So let's just say sometimes in let me draw this up. So sometimes in metal there will be empty spaces inside. For example, let me duplicate this real quick. No, wait, oh, right. Oh, what happened? Like this, it will be closely packed, but something is off about it, right? One of it, one of it, there will be empty spaces that is yet to be covered. Oh, come on, man. Oh, for example, like this. When you hit something with a hammer as it changes shape, the ball in here, when you hit it right here, it will go in. In the atoms of pure metal, there are some empty spaces. Upon knocking metals, atom will slide over each other easily. See? For example, this is let's just say I apply force here, as stated right here. And then this thing will slide into here. Wait, let me draw it a little bit nice. It will slide into here, filling the empty spaces, and it will um change shape. For example, let me draw it up. So let's just say, as the picture shown above, it's shaped like this. So when you apply force to the side, maybe it will go something like this. Yeah, see, it changes shape. This is for pure metal. Now, if exams were to ask you what you should do, well, first of all, you write it like this. There are oh, so- there are empty space between metal atoms upon knocking or hammered. Anything is anything is fine. Either of those metal atoms will slide into empty space. See, the statement is correct, by the way. You can see it. It will slide into empty space. See, it will slide. It will slide. So that's really it about pure metal. Now we are done explaining pure metal. Let's go on with alloy. All right. So what are difference between alloy and supermetal? Okay. Now, for example, let me see. Alloy. The difference is, as you can see, pure metal, punya properties. Pure metals punya properties, they're same size of atom, and blah 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 blah, and blah 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 blah. You remember closely arranged in an orderly manner, closely packed into each other, all of that. Now, for alloy, for alloy, alloy is different. Alloy, um, alloy has punya size, different size of atoms is different size of atom, and then um less orderly arrangement. What does this What does this mean? Well, let's check it out. For example, in the bottom one. So this is pure metal, both pure metal. Pure. And you see it's match the characteristics of closely packed, orderly arranged. Now look at alloy. Alloy, you can see it's at first you can see it's orderly arranged, and then suddenly, oh, the size of the atom increases, which mean see not all of them the same. They have two different size. One is big, one is small. Now, if you go on to the third A, see it's not in an orderly manner anymore. See, it goes down, it goes up. It's not clean anymore. Now, this not only happens when the alloy of atoms are big. This can also happen, for example, or like this. Oh, yo. It can also happen like this. When atoms are closely packed, and then suddenly there are some tiny atoms that borders. I can see above it shows big atoms and small atoms. This is small atom and even smaller atoms, like tiny bits of them. Credits to Martin Theo Chemistry for teaching this. Now, you can see this is smaller atoms. You see different sizes. Not every atom inside here is the same. Both are different. They got big one, they got small one. They got small one, they got even smaller one. Now, how does this affect the properties? Okay. First of all, let's go for purpose. Why do we need alloy? Well, in alloy. Wait. Let's go for purpose. Purpose of alloying. First of all, it is much more stronger and harder. Alloy is more shiny, higher resistance of corrosion. Slash do not rust. See, it follows these purpose. Why is it stronger? Why is it more shiny? Why is it harder? Well, as you can see, first of all, it's not arranged in an orderly manner, which means it's even harder for sliding to occur. The sliding that happens in ductile, it's harder for this thing to occur, the sliding. Now, let me explain why. Let me show you the answers and then I'll explain it in an analog. So, in alloy, addition of foreign atoms. What is foreign atoms? Well, first of all, let me explain. This is pure metal A, pure metal B. They're both weak. We combine, and then it becomes like this. This is atom. This is a foreign atom. It's different. Both are different. Introduce introduce this guy with someone else, someone foreign, orang luar lah, orang asing. So let's continue. Foreign atom with different size will make arrangement too tiny. Will make arrangement become less orderly. Now see, when I add something big, see, it borders the rhythm. See, lepas add this, it can't go straight anymore. It has to go down. Now, thus making it less orderly. Yeah, less orderly. Now, when force is applied, it's harder for atoms to slide over each other. Why? Okay, let's just say for pure metal, you got for example, you got a wheelbarrow, a wheelbarrow. Now, This wheelbarrow, you try to push it. This is the wheelbarrow. Now, let's just say someone were to try and push it. This is for pure metal. This is for pure metal. And when it's orderly managed, see, it's straight, same size, the road is same size, no border. You can just slide it over very easily. No problem. Now, let's just say for alloy. Alloy suddenly we got rocks here lah. And then this road tiba-tiba tenggelam sini lah sikit. And then tiba-tiba ada batu besar sini, tiba-tiba ada batu kecil, ada gangguan. There's a slight complication because it's not orderly managed. Different sizes of all that. So when you try to push, susah lah, lebih susah lah dia akan tiba-tiba benda ni kan. Naik, tiba-tiba jangan sampai je sini, turun. Susah, kita susah nak bagi dia slide. So that's why it's the same for this thing. Now, I guess that's all for alloy, but before that, let's go on to the classification. Type of alloy, right? The name. Okay, this is if I'm not wrong, this is the only alloy you need to memorize. Actually, let's pewter. We don't need pewter. It's not in the textbook, if I'm not wrong. I don't remember, but we don't need. Let's just ignore and focus on the others. So, for your knowledge, for your info, you don't need to memorize the percentage. Just memorize the materials. Now, let's go with bronze. Bronze, it's copper and tin. Now, before we go on to the type, we need to know its main primary punya metal. Why? Sebab kita macam atas ni, kita buat injection. Kita masukkan pure metal B ni masuk dalam ni supaya dia jadi gangguan, dia akan jadi lebih susah. Macam katalah, for example, Captain America. Badan dia manusia kan? Tiba-tiba kita bagi dia injection. Injection tu, dia jadi buff. Kan, buff kan? Lepas tu, dia jadi buff. Tapi, the main material is the body. So, let's just say the main primary material is the body lah. Now, let's go with this one. Okay, bronze. The primary item is copper, and the secondary is tin. It's hard and strong, does not corrode easily, and has shiny surfaces. Shiny surfaces. Sebab apa? Sebab dia diguna untuk bina statues, monument macam Ulu Taga, and then making of swords, medal yang di Olympic tu, and artistic materials. Now brass. Brass, dia copper and zinc. Main dia copper lah. Dia harder than copper. Yes, harder than copper sebab copper is pure metal. Pure metal. Just say harder lah, harder strong. Boleh buat musical instrument macam if you see on piano, brass. Mana brass? Yeah, this one. As you can see, there are the brass here. See this one? Brass. And then this one is the brass and everything like that. So it's used in a musical instrument. Now steel. It's iron and carbon, and the main one is iron because it's 99%, but you don't need to memorize the percentage. Hard and strong, the characteristic, and it's used in construction, building of cars and railway. Now stainless steel, shiny, strong, does not rust, and its main is iron. It's made with iron, carbon, and chromium to make surgical instrument. Why? So let's just say you pergi potong orang, and then you pergi potong orang, you basuh lah, tapi you tak lap betul-betul. Lalas benda tu berkarat kan, ada berkarat sikit je. And in order to carry out surgery, you need everything to be clean, sterile kan. Tiba-tiba you potong orang tu, next thing you know, mati. Why? Sebab benda yang potong tu berkarat. Wait, let's just search it up. Can rust kill you in surgery? Using, yeah, you see? Okay, potentially be fatal because corrosion can protect. Ah, yeah, yeah, yeah. See, it's like that. Okay, now let's move on to this very popular duralumin. As you can see, alumin, of course, the main is aluminium, copper, magnesium. I think manganese you don't need to memorize. Now, what's special about this? It's light, it's strong. Guna untuk buat aeroplane dengan bullet trains. Why? Just katalah, you terbang, you guna steel. You guna steel. Tapi memang kuat, yes, it's very strong. But, you try take off, tak boleh terbang, gemuk sangat. Terlalu besar. Reference to someone lah. And then, duralumin, if you use duralumin, it's the same thing, except it flew and it actually works because it's light. Yeah, see, simple. And I guess that's everything for you. This video is for my homework. So let me make the title card. Thank you. Thank you. All right. Thank you. See you next time.